Well, hello there.
This video is an introduction to analogical reasoning, the principles of analogical reasoning, the application of analogical reasoning, and argument through analogy. This is not meant to be or intended to be an exhaustive, complete study of everything connected with or pertinent to analogical reasoning. For our purposes and in everyday life, there are basically three forms of reasoning: analogical, inductive, and deductive. These are the ways in which we use information to arrive at conclusions, find solutions, find answers, correct problems, acquire new knowledge, or just generally try to figure things out. The most basic form of reasoning, on which other forms depend in one way or another, is analogical reasoning, or the use of analogies. Analogical reasoning is reasoning based on the use of analogy. Analogy is the comparison of two items. The two items that are being compared are referred to as analogs, but are referred to technically as cases. Of the two analogs, one should be well known with a body of knowledge behind it, and so is referred to as the familiar case. The second analog, about which much less is known, is called the unfamiliar case. Analogical reasoning proceeds from this idea. Since the analogs are similar, either in many ways or in some very important ways, then they may also be similar in other ways. If the two items are strongly similar in certain ways, then they may also be similar in other ways as well. If there are many similarities, or if the similarities are strong or significant, then the analogy is referred to as a strong analogy. If the analogs are different in many ways, or if the differences are significant or important, then it is a weak analogy. If the two items being compared are both unfamiliar, then the conclusion is especially weak and highly questionable. If the two items being compared are both very familiar, then the conclusion may be reasonably strong. Conclusions arrived at through strong analogy are fairly reliable. Conclusions reached through weak analogies, on the other hand, should receive little consideration at all. Therefore, when you are confronted with an analogical argument, stating that this thing here is like that thing over there,
The first thing to ask regards the features of the two analogs, the features, the factors, the elements, the parts of each of them. What of the analogs is important or relevant or related to the conclusion? Are the features similar between the two cases? Remember, we have to compare them to look for the similarities. If the features of the analog are relevant to the conclusion, and we have to ask whether those features are similar between the two cases. If those elements are present in both of them, that means that they are similar, in which case we may have a strong analogy.
Are the two analogs very similar, or are they very different? If the similarities are many or are significant, then the conclusion may be strong. On the other hand, if the two items are different in substantial ways, you should discard the analogy, disregard its conclusion. Bear in mind, though, that no analogy is perfect. They can only be stronger or weaker. To decide whether an analogy is worth considering, we first have to pick it apart, analyze it, dissect it, to find the similarities and the differences, and to see how strong the similarities or differences are, or how many there are. Do not forget that the first rule of reason is this: the one stating a claim is the one who has to prove it, whether that is your claim or someone else. If someone says to you, this over here is like that over there, that person is making an original or positive claim. She is the claimant, and so is obligated to prove that claim. It is not the responsibility of others to disprove the claim. So, anytime you make an original or positive claim, it is your obligation to prove that claim. For the most part, whenever a statement contains some kind of comparison, the argument is likely to be an analogy. Comparatives, that would include words such as like, similar, compare, contrast, resemble, juxtapose, parallel, many others. If one of those words is present in an argument, then the argument may be an analogy. Commonly, analogies are the basis for parables, allegories, and forms of writing that try to give a moral or teach a lesson. If you've ever read a story or heard one that had something at the end like, "And the moral of the story is," the author was trying to give an analogy. Or the author may simply imply that there is a lesson to be learned from the story. For example, Aesop's fables are well-known examples of analogy used in writing, but the moral of the story is seldom pointed out clearly. Take, for instance, the story of the ant and the grasshopper, one of Aesop's fables. The story makes a comparison between the hard-working, industrious ant and the foot-loose and fancy-free grasshopper. The ant gathers and stores food all summer to prepare for winter. The grasshopper fiddles around and plays around all summer, giving no thought for tomorrow. Then, when winter comes, the ant lives warm and comfortable, while the grasshopper starves, freezes, and dies. The analogy here draws a comparison between being industrious and planning for tomorrow, as opposed to living thoughtlessly, as though tomorrow will never come. The first case, being industrious and planning, is shown to be the wiser course in life. Many religious texts rely on argument from analogy in the form of parables. Some short stories, novels, movies, plays, songs, videos use analogy to suggest a lesson for everyone to learn from and to live by. In examining fiction, however, it is never a good idea to presume that the story, any story, every story is intended as an analogy with a lesson to be learned. They simply are not all analogies. Not all stories are parables, fables, or are trying to convince through analogy. Take The Lord of the Rings, for example. J.R.R. Tolkien repeatedly and strongly proclaimed that Lord of the Rings was not a parable, did not use analogy, and did not suggest any kind of hidden meaning in the story. Despite this, people have continued to try to find a message in the story or to draw parallels between different lifestyles, government, societies, or science versus nature that could be pulled from the story in comparison with modern life. Really, sometimes a story is just a story. As these examples show, analogical reasoning is often used in moral reasoning and moral arguments. Examples of analogical reasoning are often found in ethical or legal debates over contentious or controversial issues such as abortion, gun control, medical practices of all sorts, including vaccinations and transplants. For example, in abortion, there is an analogy that is used often that compares a fetus to an acorn. Now, how similar is a fetus to an acorn? What are the differences? Is this a good analogy? The problem here is that it forgets the first fundamental principle of argument from analogy, the similarities between the two items. We have to ask the right questions. Which is the familiar case? Which is the unfamiliar case? What are the important features of each case? Are those features relevant to the question? Which of the features are similar? Which of the features are different? Are there many or significant similarities? Are there many or significant differences? What are those similarities and differences?
Only after we answer those questions can we decide whether this analogy is strong or weak.
This argument fails on all of those accounts. There are only one or two similarities, and neither of which are relevant to the issue. There are always differences of some sort or another, and if those differences are significant, then acts based on those conclusions can be awfully wrong. In recent years here in the United States, arguments have been presented in the debate over gun control. Some of these analogical arguments have tried to draw conclusions based on comparing the United States with other countries like Switzerland or Japan. Those analogies do not take into consideration the many and significant cultural differences between those nations and ignoring those differences to arrive at their conclusion. Thus, those conclusions are highly questionable and probably should not be used as the basis for any decision regarding private ownership of firearms. Here are some short little analogies. Consider whether these are strong analogies or whether they are weak.
Think, men. Think.
Think about the differences between them, the similarities between them, to decide how many things are similar, how many things are different. Are the similarities significant? Are the differences significant? Then we can figure out whether they are strong or weak. First, my love is like a red, red rose. Second, owning a gun is like owning a car. Tomatoes and apples are similar. Apples and oranges are different. You can understand comets by thinking of them as giant snowballs. Now, are those strong analogies or are they weak? There are two categories of analogy. There are formal analogies and physical analogies. Let's talk about formal analogies. Formal analogies are simply those presented in words alone. In fiction, formal analogies are often referred to as similes and metaphors. Formal analogies are what most people think of when we talk about analogies. Take, for example, in an episode of the television cartoon series The Simpsons, Homer Simpson presents a formal analogy to his son Bart. Bart asks Homer to explain women. Homer uses a formal analogy in which he compares women to beer.
Dad, I have some questions about women.
Can't you see I'm reading the, cultural calendar? Oh, wait a minute. Actually, a woman is more like a beer. They smell good. They look good. You'd step over your own mother just to get one.
Obviously, Homer is presenting an exceptionally weak analogy, since both cases are unfamiliar to Bart. The analogy is also weak because there are many and significant, strong differences between women and beer. This analogy further suggests that to Homer, women are nothing more than something to be used or consumed and then tossed aside. He is denying their fundamental humanity. Formal analogy is also found in statistical arguments when you compare statistics between known information to reach conclusions about future possible conditions. By comparing records of medical histories, for example, it's possible to draw conclusions about diseases, conditions, their causes, and treatment. Since we know that many people who smoked cigarettes in the past contracted heart and lung diseases, we conclude that those who are smoking today may be subject to contracting those same diseases. Formal analogies also includes scientific notation or mathematical formulas. Einstein's famous formula, E equals mc squared. Newton's formula for the force of gravity. These are formal analogies. The basis for those particular forms of analogy is that today will be much like yesterday, and tomorrow will be much like today and yesterday. Physical analogies compare physical items. physical items that can be seen, felt, heard, smelled, tasted. They can be handled. In education, these are referred to as manipulables, something that can be held and manipulated. There are two kinds of physical analogies. There are models and simulations. Models are simple analogies. They are simplified versions of the reality that they resemble. For example, dolls and mannequins and dummies are physical analogies of people. A doll is much simpler than the being it represents. Barbie, for example, does not have heart, lungs, kidneys, liver, pancreas, or intestines. She will never be able to reproduce. Being lifeless, she has neither emotions, feelings, hopes, dreams, goals, nor ambitions. Barbie dolls are meant to be only a rough, simple analog to a real woman. When you take CPR training, you have a dummy that you practice on. The only features of the dummy, it looks vaguely human, but it probably is missing arms, legs, and other features, and absent hair, and it's not thrashing around like, someone choking to death. The only features are those that are pertinent to the training, so it's a simpler version. So it is a model, an analog. Models can be used in meaningful or significant ways in order to learn more about phenomenon, to consider possible future conditions, to learn, to teach, to train. In the aerospace industry and the automotive industries, models are used to test for the effects of airflow and their effect on stability, mileage, or other issues. In medical practice and pharmaceutical industries, animal-based research uses analogical reasoning by comparing the results of medications or procedures on rats, pigs, or other creatures to suggest that similar results might be found in use with people. If a medication or a chemical or a treatment produces significant negative effects on rats, for instance, then analogical reasoning suggests that the medication or procedure might have the same negative effects on humans as well. If there are significant positive results with rats, guinea pigs, monkeys, whatever, then the same result may be found in human use. Such studies, however, are often questioned because there are significant differences between human beings and rats, bats, cats, stoats, goats, pigs, or other non-human beings. Don't forget, analogies are always only approximate and never provide exact conclusions. As these show, we sometimes use models in inductive reasoning, inductive arguments, empirical reasoning, and science. The most familiar example of this, scientific analogical models, would be the weather maps that you can see on television, online, on your telephone, or wherever. The information in the weather map is presented in a simple graphical form to show what is currently known and what that means for future conditions. The weather map is a highly simplified version of what is actually happening in the atmosphere. The other kind of physical analogy is simulation. Simulations are more complex versions of the realities which they represent. Perhaps the best known form of simulation are those used for training pilots. Flight simulators. Flight simulators require a lot of machinery, much more than their real-life counterparts, and are often far more expensive than a single example of one airplane. Simulators require many mechanical elements. They require lots of software to support them, and there are lots of technicians, trainers, and other people associated with them. However, simulations can provide useful, valuable information and experience that can lead to significant positive results and may be an effective and cost-efficient way to gain new information or to teach or to train what is currently known. Think of it. When you crash a flight simulator, nothing is damaged other than maybe your pride. But when you crash a $45 million airplane, there are massive costs in time, machinery, resources, and personnel. Although flight simulators are complex and very expensive, their use in the military and the aerospace industry has saved untold millions of dollars and thousands of lives. On an everyday basis, we all use analogical reasoning. Each and every day, we think that today will be much like yesterday. So you wake up, get dressed, go home, clean up, go to work. You proceed based on the everyday similarities. We look out the window in the morning to see what the weather might be like and form an analogy between what we have learned from the past and what we are currently observing. We look out the window and we see that there are high winds and dark skies, and we know from previous experience that high winds, dark skies results in rain. So we conclude by comparison that similar conditions today will yield similar results as in the past, and so we prepare for having to deal with rain. We compare what has happened in the past with what is happening right now and come to a conclusion about the future based on the similarities and the differences. Analogical reasoning can provide us with meaningful information, but it does not provide a basis for especially strong or accurate conclusions, as we all know from the many times that weather forecasts have been seriously wrong. Analogical conclusions, therefore, should be treated carefully, keeping in mind that the conclusions are suspect and prone to error.